Hi, here to talk to you today about Vertigo 3, a new class of underwater robot. Let's deal with the logo first. It's clearly designed to be a high-performance aeroplane, by which we mean 3-axis controls along with flaperons, working underwater, sensing the bottom primarily by vision, and producing interpreted data as it goes. Whole purpose of it is for broad-scale survey. Reefs, yes, shallow waters in general, more specifically replacing the old man-to-tow method, which was invented 51 years ago. Let me just clarify that there's already 3 classes of underwater vehicles at the moment: TUVs, towed, brick on a string; ROVs, sluggish robot on a string; and AUVs, sluggish robots without strings. We've very deliberately opted to use a cable to tow the glider with, and that overcomes the 3 critical issues for broad-scale work underwater. 1, it allows us to geolocate. 2, provides the great majority of the propulsion force. And 3, it provides all the communications bandwidth we need for performing high-performance computing on the surface using the information as it's coming in. Because of all of that, we can build something that's very, very fast, agile and small, and therefore allows us to operate in topographically complex regions such as bommies and coral reefs. Multiple use cases. It was originally conceived for crown of thorns starfish management, but equally applicable to a whole range of other surveying, censusing, stock assessments, etc. The data management side of it, the primary vision stream is 15 frames a second, 5 megapixels per frame, plus a whole bunch of associated IMU data and glider performance data, all of which is stored and archived, and every pixel is available for the future. Meaning that using the glider and collecting this type of data, we can actually answer questions in the future which we have never contemplated today. It's very unlike any of the current monitoring techniques which are used. The other thing, of course, is a lot of the money that gets spent on this is public money, and in this sense, the work of this is fully auditable. We just got back from a 10-day trip to the Great Barrier Reef, did a whole bunch of work on flight path control and things like that. But at the same time, we took the chance to go and survey Fitzroy Reef, 24 kilometres of around the reef edge, including a number of places where we towed at multiple depths in about 3 hours, a little over 3 hours. Fitzroy Reef Shoal, down to 20 metres water depth on the edge of the shoal in under half an hour. Llewellyn Reef, 2 hours and 6 minutes to tow the entire reef. Lamont Reef, back reef area, 40 minutes to tow 4.7 kilometres. And you can see from the moving video there that we're identifying animals, particularly crown of thorns starfish in this case, for our training. The other things that the glider is good at, and we are building ML capabilities for, is multi-species classifications of seagrasses in Moreton Bay. And you can see from that imagery we're getting quite good test results there with 88% recall and precision for our poorest species, which is the rounded types of seagrasses, but generally high 90% for seagrasses in general. And given that we are analysing this every 15 centimetres or so, gives us a very, very high precision in terms of our community estimates. The other thing, of course, is the fact that we are running video allows us to do things which haven't been able to do in the past. So, for example, tracking the movement of fishes and stuff like that, frame to frame, allows us to identify and segment for training purposes, but also for ecological purposes, counting. Thank you very much.